Well, good evening, everybody. Thank you for joining us for our webinar on building number sense, part of our middle school summer series. I'm pleased to introduce Deb Heckathorn, one of our Casio advisory teachers, and without further ado, I will pass it over to her. There you go, Deb.
Thank you, Nathan. Good evening. This webinar is part of a series of webinars geared toward middle school and the Casio Fostering Series. This evening, I would like to work with you with building numbers and with integers. Hi, my name is Deb Heckathorn. I am a retired teacher and supervisor of mathematics for the Oil City Area School District in Oil City, Pennsylvania. I taught for 33 years and was supervisor for 10 of those years. I am very proud of my years of teaching, and I pray I made a difference to my students. I actually only taught 2 of my years in middle school. I must tell you, I remember saying to my son when he was in middle school, "Andy, you're not thinking." Then I read an article somewhere, and it stated that at that age their body is going through so many hormonal changes that they literally can't think. I have a very great respect for all of you teachers of the middle school. It's just an unbelievably difficult job. Although I'm enjoying my retirement, I found a need to share some of my experiences with other teachers. In other words, I missed it, but not enough to substitute. Tonight, we'll be talking about integers. The goals that I have for this evening is, first of all, you'll be given a visual, hands-on explanation of integers to use with your students. Addition, subtraction, and multiplication of integers will be included. The division is just an inverse of the multiplication, so it could be added if you would like. You'll be given an investigation for students to discover why a coordinate system is used when graphing. This will be followed by a more in-depth discussion of integers using a PRISM calculator, which will include absolute value and graphing. Now, first of all, when building a human number line, this is a good way to introduce the integers to the students. One of the best ways to start this is to put a line on your blackboard or someplace on your wall in the front, whatever you have, and then you just pick out any student in the classroom and say, "Count for me." And they'll always start off with number 1. I've done this over years, and nobody ever starts with 0. They always start with 1, which is the first of the counting numbers. And then you take the 1 and you say, okay, you started off with 1. We're going to start a line, and we're going to start off with number 1. Who wants to be 1? And then you give the student, and this brings your students into working with the integers. You mark them a 1. You stand them up on the number line that's on the front of the room. And then you say, what's the next number? They say 2. Who wants to be 2? And then you keep repeating them, keep building it until you have the numbers from 1 to 10. You would also like to, at this point, discuss that those are your counting numbers, and they're also called natural numbers. And actually, it's easy to pick out how it gets its name because you count naturally starting with 1. Now, I want you to notice I don't have a classroom, so I use clip art for mine. I want you to notice I have a very well-behaved classroom. Quite diverse, but very well-behaved. At this point, it's best to start demonstrating addition. Use only these counting numbers that we have on our number line. And for example, if you demonstrate 2 plus 3, what you'll want to do is stand at the 2. So you're standing in front of the number 2 student, and you'll say, okay, if I want to add 3, where will I have to go? Well, the students are going to tell you that you want to move to the right 3 places, and then you land up at 5. So 2 plus 3 is 5. Then ask the students where you move if you add 1 more. Add 1 again. And after doing this for a few steps with addition, you would like to say to them, okay, now, what do you notice about addition? What direction do you always move? Or lead them into figuring out that when adding on a number line, you will be moving to the right. And after that is done and the students realize you're moving to the right, for addition, you just do the same thing with subtraction. Okay, let's demonstrate 7 minus 3. So now you'll stand at the 7. If you're subtracting 3, let the students tell you. You'll be taking those numbers away. And when you take the 3 away, you will land up at the 4. From the 4, you may want to say to them something like subtract 2 more, subtract 1 more. And what direction do you always move when subtracting? This is going to have the students down to where they know that adding, we're moving to the right, subtracting, we're moving to the left. Now you're going to start off at 1. And you want to subtract 1 more. What happens? Well, the students are going to say we ran out of numbers. And you can add, did we run out of numbers? What number is next? Let them lead into where you can have a 0 at this point. And when they do, say, okay, who wants to be the 0? And you put 0 up there. These numbers from 0 to 10 and all the numbers above 10 are called the whole numbers. They're the same as the counting numbers. The only difference is we've added the 0 to it. If you were in a store with $2 and you spend or subtract $1, how much is left? Do the subtraction on here like you did before. If you spend 1 more, how much money do you have? Which direction are you always moving? Now, can you spend another $1? You're right now at 0. Can you spend another $1? Now, most of the students at this point will say, well, no, we're out of money. Well, you can say, well, if you go into the cafeteria and you don't have your money, does that mean you cannot get lunch? And they might say, oh, no, we're allowed to charge it. When your parents go to the store, they don't have the money right there. Can they buy you a pair of shoes? Well, they might be able to charge it. You might want to have a little discussion at this point on maybe credit cards and using them to take care of the cash temporarily until you do have cash. Also, IOUs. Now, at this, can you spend another $1? Well, sure you can. Then you can charge it, but you'll be in debt $1. In debt $1. That means we're going to have to add a -1. Okay, who wants to be the -1 and get everybody up to the -10? Now you've got a whole classroom of people going from -10 to 10, and we've got lots of things that we can add, subtract, and multiply and divide. You also, at this point, would like to introduce the term integers, which is what we're leading up to tonight. The integers are all the numbers negative through positive. Now, demonstrate addition and subtraction of integers. This time we're going to start off with -3 plus 2. Okay? If we start off at -3 and we add 2, they already told us that we're going to move to the right for addition. So you add 2 and you land up at the -1. So therefore -3 plus 2 gives you -1. How about -3 minus 2? Starting at the -3 minus 2, you're going to move to the left 2 places. You land up at the -5. Now what happens if you have a negative 3 minus a negative 2? Now remember, whenever you have the negative 3 that we're starting from and subtract. Subtract means we're going to move to the left. Only this time it is a negative 2, which means you're going to move to the left, but then opposite, which makes it to the right. And so therefore this would turn into the same thing as negative 3 plus 2. So therefore you might want to point out and even write it on the board and show them that the negative 3 minus a negative 2 will be the same thing as saying negative 3 plus 2, which is the negative 1. Now let's demonstrate some multiplication. The multiplication is really not near as hard as what you think, and it's very easy to demonstrate with the number line, the multiplication of integers. The only thing is to begin with, when you're starting off with the students, it would probably be better to either start at 0 or end at 0. After they get the hang of it, you might want them to play around and to work at it, and maybe even work with the number line at their desk to see the adding and subtracting in other problems that do not start at the 0. But we'll start off at the 0, and we're going to start off with 2 times 3 is 6, and we're going to demonstrate that. A good way to have for this one is if you receive 2 birthday cards and they each have $3 in it, well, that means you have one birthday card that has 3 in it and another birthday card that has 3 units in it. So you have 2 groups of 3. Notice that in this case you have gained $6 then. Not just the 2, you have 2 groups of 3, which is the $6. To demonstrate 2 times negative 3, this would mean that you purchased 2 items on credit for $3. Okay, there's the one item on credit for $3. There's the other item on credit for $3. So now, notice that you have moved to the negative 6 from 0. So 2 times negative 3 is negative 6. Now to demonstrate negative 2 times 3, this means that you're giving away 2 items, but each of the items costs $3. Let's start off at the 6. I'm going to give away one item of $3 and another item of $3. That, since I am now removing 2 items where each of them are $3, I have removed 6. By removing 6, I have gone down 6, or negative 6. The hardest for both students and teachers to picture is when you have a negative times a negative. In this case, we're going to start off where you're $6 in debt. So we're at negative 6. And this time, your parents came along and they found out that you have a credit card. And they say, no dear, no credit cards. And your parents remove 2 IOUs, or 2 credits, of $3 each. So they're going to remove this negative and that group of 3 negatives. This would be the same as saying negative 2 times negative 3. Now, how much money do you have now? You first of all start off, you're $6 in debt. If they paid off that, you landed up at 0. Did you gain or lose money? Notice that you did gain. You gained $6 because you went from $6 in debt to 0. Therefore, a negative 2 times a negative 3 gives you a positive 6, or a gain of 6. Now's a good time to explain the meaning behind absolute value as the distance from the number to 0. In other words, if you have the absolute value of 6, the number 6, absolute value is actually saying to you how far away is the positive 6 from a 0. And notice that you move 1, 2, 3, 4, 5. The 6 is 6 units away from the 0. In the same way, if you have the absolute value of a negative 6, you are actually asking how many units away from 0 is the negative 6? Well, again, the negative 6 is 1, 2, 3, 4, 5, 6 units away. They're not negative 6 units away, it's 6 units away. And that's why a negative 6, the absolute value of a negative 6 is a 6, and the absolute value of a 6 is a 6, because you are talking about distance, not actually the value of that number. With the absolute value, at this point, let the kids discover this themselves, but you just want to say to them, explain why. A negative 6, absolute value of a negative 6, then subtracting 2 is 4. But the absolute value of negative 6 minus a 2 is 8. These two, a lot of times, the students think that they should be the same answer, and they are not. Let them decide, and remember to have them use the absolute value as the distance of units and to work with this. Let the students, after discussing it, explain why. By the way, you're going to see these two examples again later on when we start using the PRISM calculator. I just don't want just to move it, to bring it out yet. We're going to get some investigations going first for the students to use, and then we'll bring the PRISM calculator into it. Also, when the students decide exactly what's being done here, you might want to stress the fact that when working with the absolute value in the order of operation falls in the same category as parentheses. So with the please excuse my dear Aunt Sally, the absolute value falls with the P, the parentheses. And that's why this one, the negative 6 minus 2, has to be worked out first. The absolute value is worked like parentheses. So make sure that they are leading into this and explaining the difference between these two problems. It all comes down to the order of operation. Now we have an investigation. What you would want to do here is divide the class into groups. We've already introduced where the integers are. Have each group blindfold one of the students in their group. Each group should be given we'll give the blindfolded student a piece of paper with just a dot marked on the paper, and they have a pencil. One at a time, let one of the students in the group give directions to the blindfolded student so that they move their pencil in to the dot that's on the paper. When done, ask the students what method they use to lead the blinded student to the dot in the fastest time. You should find that the students' directions that work best would be given not only a direction for the student to move, but they also maybe have a unit of length. Like say move about 2 inches to the right, 1 inch down, or time. For instance, they might say move your pencil to the right till I tell you to stop. Now move the pencil down till I tell you to stop. In this case, they're using not just the direction, but they're using time. But you will find out the best directions will always have two different things, whether it's directions and length, directions, time. Now, keep the students working with this and find out which one really is the best as far as what they're working with. After after you've done this and that investigation, you can do another one. It's using the same thing, but this time in each of the group, you want to give them 2 number lines. We've already introduced the number lines, so they know where the number lines, and they have the integers, positive and negative numbers on it. And then you say, can these number lines be placed on the paper in such a way that you could determine where any point is located? Once they've devised a system, plot 3 points on their paper and say, could you give easy directions to another group to plot the same 3 points that I put on your paper, and have them get them in exactly the same location on their paper, and then discuss the systems. Let the students come and explore, and it is best to have the students explore before you ever explain the whole system of ordered pairs and so on. Let them devise the system. Why was this the easiest system to do? How does this make it easier? After this investigation is done, it would be nice you could introduce the terms such as Cartesian coordinate system, origin, axes, horizontal axes, vertical axes, ordered pairs, x-coordinates, y-coordinates. You might want to also say, when you're talking about ordered pairs, does it matter which number's first? In other words, if you give the ordered pair where there's a 3 then a 2, is the 3, 2 the same thing as a 2, 3? Have them discuss it and to see if they're the same points. When they find out it's not the same point, you might say, okay, let's make a roll. What direction should I move first? Which one should be the first one? And you can say, and you can even point out that you have the x and the y axis. Okay, which way do you want to move first? They might say, well, let's do it alphabetical order, x before y, and then jump on it and say, okay, that sounds like a good idea. Let's put the x before the y, and that'll be our directions. Let them know that they could do the y before the x, but the system, once you do give them the system, you'll have to tell them that it's going to be x before the y, and so therefore try to lead them into that right now and then not confuse them later. Now, the integer topics that we're going to use using the PRISM, I'm going to show you as a teacher some things that you can do with the PRISM, and I'm going to show you about the absolute value of chords, set up and setting the windows, the view window. I'm going to show you how to use dynamic graphing using different integers for slope and the y-intercept and bringing in linear equations at that point. Graphing lines, slope and y-intercept again, only this time we'll be using the graph mode. Then we're going to do plotting points using picture plot. When we're in picture plot, not only are we going to plot the points, but I'm going to show you how to bring up the list of the points that you plotted and also determining the regression. When that's done, we're even going to go to the geometry mode, which is something we usually don't do at the middle school, but it is nice. And we will plot points in the geometry mode. First of all, we're going to do absolute value. Now, there are 2 methods to get to the absolute value on the PRISM, and I want you to notice that the problems we're going to discuss are the same 2 problems we looked at before. I told you they'd be coming back. And what I'll do is I'll show you one method with the first problem, and then I'll use the other method of working with the absolute value with the second one. I will bring up my calculator. There it is. PRISM, it's just such a wonderful calculator, in color, beautiful. Okay, in order to work with the absolute value, we're going to stay in run matrix mode, and that means that we are going to go to this very first one. You can press a 1 to get to the run matrix mode, or just highlight it like it is here and press execute. If you have anything on your screen at this point, you would want to delete it. Notice the delete is over the F2. We can press F2 and then say delete all. F2. Delete all? Yes, F1. Okay, mine was already clear. I didn't have to do that. Okay, the first method, this is one that you can use when you are on most any screen. Not always will you have the math on here, which is the second method, but it won't be there. But I want you to notice that there is an option key. The option key, if you press that, you get this list right here. Over the F3 is complex. If you press F3 for complex, notice absolute value is right over F2, and then you can press that. Now the first one, we're going to do the absolute value of -6. By the way, the Prism, it's so nice that on many calculators, as you know, when you press in the -6, if students would accidentally press in the -6, it gave you an error. The Prism does not do that. It will accept the subtraction sign. But I just did fill in the -6. Before I fill in the -2, since the -2 is on the outside of the absolute value sign, I have to move my cursor to the right, to the outside of the absolute value, then press the -2 and press the execute. And notice we did get the answer of 4. Now we're going to hit the exit to get back onto the original screen, and I will show you the second method. This one's a lot faster, but again, you will have to have the math on the screen. Where it says math above F4, whoops, execute it. I'm going to delete what's in there first. Well, we'll just leave it at that one. When we go through the setup and setting the view windows, which is the next part, notice that with the setup, what we want to do in setting it up, I'm going to show you because we're going to need it. We're going to turn on the coordinates, turn on the grid, and turn on the axes. When I get to the view window, I'm going to show you how to set it up for standard. I'm going to go back to the calculator, go back to the menu, and since we're going to be graphing, we want to go to graph mode. Now, I could move this down and highlight graph and press execute, but this time I'm just going to press the 5, which will bring it up also. Now, when I press the setup, I'll get to this screen. Notice the magenta arrow pointing down. That means that there's more things to choose from. That's a good thing because everything I want is going to be further down. There's your coordinates. I want to turn on coordinates because I'm going to be working with plotting points. Scroll down again to the grid. Not only am I going to turn the grid on, but I'm going to turn it on as lines. The reason is because that'll turn my screen to look like a piece of graph paper. And go down one more to the axes, and I'm going to turn my axes on also. Now I'm going to exit, and now I'll show you how to set up the view window. Now for this one, this is the standard screen, -10, 10, -10, 10. Means that we can go to the -10 on the X, positive 10 on the X, and same thing for Y. This is the one that we're going to be using for this section, but I do want to show you over here on the initial. It's a very nice one. This one squares up the screen for you and it looks more natural, but because I need a little more numbers for what I want to do is why I'm taking over to standard. But this initial screen is a very nice one to work with, especially with the middle school students. Set this one for standard and exit. Now what we're going to start doing here, since we already have our integers, we know how to put the integers into graphing to graph the points, and we're going to now work with the integers as far as working with the slope-intercept form of any linear equation. And we're going to set up what's called a dynamic graphing. On this one, I do want you to notice that what we're going to do is we're going to start off and we are going to keep A as a constant of 1, and we're going to select B to be the changing variable from -5 to 5. When we're done, we're going to go back and do it again. Only the second time around, we'll select A as the changing variable from -5 to 5 and keep B as the constant at 1. I'm going to pull up my graph. Go to menu and notice that dynamic graph is right here at number 6. This dynamic graph is really not something that the students will want to use or something you want to even teach the students to use, but it is very good for a teacher to demonstrate different things, in this case demonstrating slope and y-intercept using the integers. Now, when you press that one, you come to this screen right here. But I want you to notice above the F5 is built in. We could fill in any equation what we want here as long as it's in the form y equals. As you see, that's what it's set for up here. But we're going to come down here to the built-in ones because the slope-intercept form is already built in. Notice they even have the trig functions built in. There's quadratics and so on. They're very nice to pull up, and they're the most common ones to use. Highlight slope-intercept, since that's what we're using, and press select, which is F1. It will fill it in here. Once you have that filled in, what you want to do is go to the variable, which is F4. Do you see how the A is highlighted? Well, we said we first want to keep the B as the one that's going to be the one that's changing. So therefore, we want to change this red letter to the B. To do that, highlight the B and press select, which is F1. That will change this to the red B. That means that we are going to have the B as the number that's going to be changing each time. Highlight your A, and we want to keep that as a constant. Let's just leave it as a constant at 1. Press execute. Now you have to press the execute at the 1 to keep that at the 1. Otherwise it would go back to any number that it was set at before we started. Now with the B, go to set, which is right above F2. Oh, good, this one's already set. You want it to start at -5, end at 5, and you want it to change 1 unit at a time. If your numbers aren't like this, all you need to do is just press over what's there, press in your -5, enter 5, and enter step of 1 unit at a time. Now let's exit. We're also going to set the speed. If you press F3 for speed, notice you have choices of going slow, normal, fast, and you can set this up where it'll change automatically one after the other for the students, but we don't want to do that on here. What we want to do is we want to go stop and go because this will give the students time to discuss what's happening. So press F1 for stop and go, and you will be in control, and all you have to do is press the execute each time you want to change. Now press exit to go back to where you were. We have our B as the variable, our A as a constant at 1. We set up our speed, and so all we have to do is turn the dynamics on. The dynamic graph will come on with F6. Now you want the students to discover what is happening to this, and so therefore you want to note, make sure that the students notice above where it says y1 equals ax plus b. Remind them that our constant for the a was 1, so every equation will have a 1 in that spot. It will be the b that changes to this number at the bottom. Therefore, the graph of this line is y equals 1x plus a negative 5, or y equals x minus 5. That's this line. Let's take it to the next one. So press execute. Now our line moved. This line now is y equals 1x plus a negative 4. This one is y equals 1x plus a negative 3. Ask the students, do you see what's happening with the B and what the B does to change the line at all yet? Some of them might say, okay, if you see what's happening, raise your hand. Let's go again. This one is y equals 1x plus a negative 2. What's happening? Y equals 1x plus a negative 1. Y equals 1x plus a 0. And keep going. Have the students write the equations down. And now they might say, well, when it changed, the line just always goes up. And you say, oh, really? Oh, all of a sudden it's going down. I'm sure it won't take them very long to figure out why the y-intercept is called the y-intercept. Now, we'll exit, and we're going to change it again. This time we're going to set the dynamics for the A. So press the exit to get back to the original one. This time we need to change this B to the A. Hopefully you remember how to do that. And that is by highlighting that A and press your select. Now the dynamic variable is changed to the A. Go to the B. We're going to keep the B constant this time as the 1. So you enter the 1 for the B. Make sure you execute. You do that? I didn't. Okay, now take it back up to the A, which is your slope. And now press F2. We might as well leave it the same. Start at negative 5, end at 5, and have 1 unit in between. Press your exit. Our speed we're going to keep at the stop and go again so that we can move it. And now press the dynamics. Okay, notice on here, this line here, remind them that the B is a 1. So the graph of this line is negative 5x plus 1. This one's negative 4x plus 1. Did anybody see how it changed? Do you see now? This one is negative 3x plus 1. Make sure that the students are writing the new equation down each time by filling in the A and remembering that our B was a constant of 1 all the time. Probably by now they're noticing the changes. And this one now is negative x plus 1. And they're going to be telling you that the slant of the line is changing. And you might want to point that out before the next one comes, because now it's totally horizontal. And this one is y is equal to 0x plus 1, or y equals 1. Press it again. Hopefully in doing this, I want to make sure that the students are discovering what is going on, and hopefully that they're picking up that it is, with the positive numbers, the line is going up from left to right, whereas with a negative slope, the y is going down from left to right. But make sure that the students are discovering this. Don't tell them. Let them discover it. If you want at this point, another nice one would be, after they pick up how the slope is moving it, you might want to go back to here. And when you go into the set the start and end as from -1 to 1, only with a step of 0.2. What this will do is it'll show them how the fraction as the slope, or the fractional coefficient, will change the line and what's going to happen with it. It'll give them a new view of some of how the line's working. I hope you enjoyed working with the dynamic. The dynamic graph is one of the nicest teaching parts of the calculator. It's not really good for the students, but it is an excellent device to use when teaching. It'll also go into this investigation, and in this case what you want to do is fill in different equations for y equals ax plus b in graph mode, and then say to the students, keep filling in different graphs. And how will integers make a line steeper? What integers will make the line horizontal? What integers will make a line rise from left to right? What integers will make a line fall from left to right? And the final one is an extremely difficult one. What integers will make the line vertical? When describing the steeper horizontal rise and fall, after they're working with this one, they might say something about, oh, the bigger numbers are going to be steeper. Well, it's not always the bigger the number, because when you go from -1 to -5, which is getting smaller, it's getting steeper. So you might want to encourage them, well, how are you going to describe this? And could absolute values help you describe it? Also, of course, with the vertical line, they'll never be able to get it vertical, will they? But let them decide that on their own. Have them figure out that getting that slope, the biggest number possible, is going to make that line look like it is vertical, even though it actually is not. Now, we will look at how you get a vertical line at a later point, but as of right now, we won't. I'll show you how to put in the x equals. It would take quite a while for the students to do and figure it out and to write it up. So it's a nice method to work with. Now I'm going to show you how to use picture plot mode when working with integers and to plotting points. In order to do this one, what we'll first do is I'm going to have you use the picture called Wooden. And we're going to plot at least 3 points on a non-vertical line. Then I'm going to show you, after these points are listed in picture plot mode, how to list the points. And then once they're listed, how to make a regression line of the points. In other words, get your line going through the points. Then when we're done with this, we'll take the picture to graph mode, and then we're going to be working with the vertical lines. And we will even have a student find a specific vertical line on the picture. So now what we need to do is bring up the calculator again. I'm going to go to Menu. And this time we want to go down to Picture Plot. Notice Picture Plot is clear at the bottom. We'll highlight it and press the Execute. Oh, this is a cute one. We have a Ferris wheel, but that's not what we want. Press Option and go into File, which is F1, and open them. You'll find on your calculator that you have quite a few pictures in there, and they are all listed alphabetical order. That amusement park is probably the second one. We want to go to the picture wooden. Now, since W is at the end of the alphabet, you'd have to scroll all the way down or cheat. Go backwards. Ah, there it is. It's the last one in the list, wooden. Once you have the wooden highlighted, press Open. And there's the one we want to do. Now notice I picked this up because there's non-vertical lines, there's horizontal lines, there's vertical lines. We're going to start off by doing any non-vertical line. I could do the horizontal, but I'll do one of the slanted ones. And let's see. Go into your options, and we are now going to plot 3 points on a line. Plot is F2. When you do that, notice that you have this magenta arrow. Move it. Pick out a line. I'm going to do this line, this bottom line. I'm going to put my first point here. You want to notice and keep in mind where the order of the points are that you're plotting, because when we take it to the list, they will be listed in order as you plotted them, not in order as they look on the picture. So be careful which one you put on first and second and third. Okay, now I'm going to go over a little more. Go up, and I'll plot my second point. And now I'll plot my third point. Did we need 3 points? No. All you need 2 points for a line, but we're putting in a third, just so we're sure it's straight. Once you have those 3 points plotted, you can list them. Now to list them, press the X to go back to the screen. Notice that list is over F3. When you press that, there's your 3 points that you plotted. The first point was at 0.7936. The y-coordinate was 2.258. Here's your second point, your third point. Now, what we want to do is we want to draw a line through those 3 points. And that would be the same as bringing up a regression line. And notice there is no regression in this list, but there is an arrow at the end over F6. That means there's more choices. And when we go there, oh, there it is, regression, right over F2. So when we press the regression, we're going to keep it in with the F1 or the X. Notice that you have choices here. Our linear equation is ax plus b. We shall use that. The other one is used in statistics a lot, but we're not going to worry about that. We will press our F1. In this case, you're given your a is your slope, so your slope is 2.3394, so on. Your y-intercept is 0.3825, so on. But here's the interesting part. The R is your correlation coefficient, and as you know, the closer it gets to a positive 1 means that the line is going to rise from going from left to right, and it will be a straight line. Notice you can't get much straighter than 0.999. That's good because we plotted them as a straight line, so we should have our correlation coefficient that is very close to 1. Now, we're going to draw it, and there with the blue line, notice it goes through our 3 points. That is called your regression line. You can go through and you can take this off and you can maybe do a vertical line or doing another line or pick a line with negative slope, maybe one of the lines coming down in this area. I gave you a good picture here so you can have many choices. Now, if they want to do a vertical line, let them. But it's going to come up an error here on the picture plot because the picture plot will not graph the vertical line for you when you do the regression and you try to put them in. But I'm going to show you how to get around that, of course. And the way to get around it, and we're going to right now plot a vertical line, I'm going to take the picture to what's called graph mode. And I'm going to enter some vertical lines just to show you how you can put them in. Now, we have to get out of picture plot, and we are now going to go to graph mode. Ooh, but how do I get my picture into graph mode? There's a linear equation, and I can take that out by deleting that. And I have to put something in. But where am I going to get my picture? To get the picture, we're going to go to Setup. So, hit the Shift menu to get to Setup. Scroll down to Background. In the background, hit your Open. What this is going to do, it's going to pull you up all the pictures that you had in Picture Plot. Go to Wooden and open it. Notice for background now that picture we had in Picture Plot is now moved to your graph mode. Making sure your coordinates are still on, your grid is online, and your axis is on. Okay, let's exit it. Now, I want you to fill in vertical lines, which as you know as the teacher are the lines x equals. And you can show the students how to get to that and how they're getting an error and what's happening. And you can even have them decide and discover that it would be an infinite number. And but we're going to show you how to put this in. Notice that you're going to go to F3, which is type. This is the y-equal equations that you're usually at. To graph a vertical line, it has to be x equals. Notice x equals at F4, and we now have changed it. Now we're going to fill in 3 vertical lines. The first one, with the x, we're going to fill in as 5/10 or 0.5. Execute. The next one we want 75/100. Execute. And then the last one we're going to do here is x is equal to 0 and execute. We have 3 vertical lines. I want you to hit draw and you can show the students how you got the 3 lines at 0.5, 0.75, and at 0. And notice that the color of the line will match the color you filled it in. The blue was 0.5, and the blue at 0.5 is the blue line. Now, since you've shown them that it has to be x is equal to a number here, and they have worked with that, tell them you would like to find out what is the equation of the line that would be right here into this, between these 2 boards. Hopefully they're going to work with it for a while, and hopefully they discover, as you know, they're going to find out that it's going through the 3. And so therefore, fill in x is equal to 3 execute. Remember, our new line is magenta. Press the execute, and notice you have that line graphed. Have them figure out what the equation is for this line or this vertical line. Have them work with the vertical lines for a while. It's nice to see the vertical lines being in use here. A lot of calculators will not plot the vertical line like this one does. Okay, let's go to the next part. Now we're going to be plotting points in geometry mode. Geometry mode, like I said, usually isn't used in the middle school, but it is a very nice mode to be working with and a very nice mode to get the students used to. So not only are we going to plot these 3 points, we're also going to connect the points with segments. You're going to determine the length of the segments, determine the measure of an angle, and I'm also going to add in area of the figure that we make. So now let's go to calculator, and we're going to go into the menu, and we are going to go to geometry mode and press the execute. Now, on this one, I do want to point out a few things before we get started. Look at the F1. Notice that we can go into a new program, so if something's on there, you can clear it out and put in the new. But I want you to press down F2, and it's very important you see number 1 and number 3. These two are ones that you do not want to forget to use when using the geometry mode. First of all, if you make a mistake at any time, undo it immediately, because the undo will only go back 1 mistake. So therefore, as soon as you make a mistake, if you undo it, you can clear it out right away. Also, whenever you're done doing a certain process like plotting a point, you have to deselect all. Otherwise, it's going to keep plotting points for you until you're done, or until you press the deselect. F3, notice this is where the point line are. That's what we're going to use, but real quick, I'm going to show you that there are more. You can do perpendicular bisectors, intersections, angle bisectors. Under F5, there's reflections, translations, symmetry. F6, you can even get into animations. But we're going to go back to F3, and we're going to press 1 for the point. We want to go to the setup, because in order to plot the points, we want to have graph paper. So therefore, scroll down, and we're going to turn the grid on for line. And since we're plotting points, let's turn on the axes so we know where the X and Y axes are. Now exit. Now there we are, we're on graph paper. Our first point we wanted to plot is the point 1, 3. So you're going to use the integers to the right 1, up 3. Once you're at this point, execute. Whoops. We took it off at the point when we went there. It's 1, execute. Okay. Now, notice that it puts the square on, and you can see the A on it, but the A will be a little more visible when we move off of it. Now we want to go to the next point, which is -3, 1. Now there is something you can do. You see the numbers from 1 to 9 on the calculator. If you press the 1, it'll move you automatically down into that section. 5 into the middle, 9 up here, 7 over here. Notice it's like setting the numbers on top of it. So instead of scrolling all the way over to the -3, 1, you might want to just even go to a 4. Okay, and then work from there. Or you can scroll from where you were, it doesn't matter. Now we're going to be going to the -3, +1. Press execute. Notice now I put the square on, and now there's going to be a B. Pick up your third point, which is +2, -2. And press your execute. There's your 3 points that you want to do. Now what you want to do is you're going to be, we want to make segments between them, but if I move this up on top of the A, and to work from A, it's going to plot a point D on top of it. I have to go into the F2 and deselect all. Now it won't do that for me. So if I go on top of point A, and I want to make a segment going from A down to B, I can do that at this point, but I'm going to also have to press line segment. Now notice that the line segment's in the screen over here, and I can press and execute. That darkens that, and now if you move to the left, notice that it is drawing a line, and I'm going to move that line until I'm on top of B. When I'm on top of point B, you'll get a square, and press and execute. It now has drawn the line. If I want to draw a line from point B to point C, I'm going to have to select the B again and then move it. And now I have a line coming across. If I didn't select the B, you'd be coming across and wouldn't be bringing the line with you. Take it to C, press execute to end the line. Now we're going to start the third line going from C to A, so press execute again at C and draw the line up to point A and press the execute. Now that line is drawn. Now we're going to find the length of each of the line segments, and so therefore you're going to go into the F2 and we're going to deselect all, because if we don't, then what's going to happen is it's going to draw a segment at the point we're going to choose. So now we deselected, and I'm going to go over a little bit, not that far, and I'm going to go down until I hit that line. Do you see the two boxes that come up and it even goes yellow? Press execute. Notice the number up here. That line segment from A to B is 4.4721 so on units long. Now I need to deselect it. And let's move down to another one till it turns yellow. Press execute. That segment is 5.8309 so on units long. You need to deselect it, and let's go over to the other one. Press execute. That segment is 5.099 so on units long. Deselect again. And this time we're going to be finding the measure of an angle. Let's do angle C. In order to do that one, select this line, but also keep that selected and come over and select this one. And when you do that, it gives you the angle 47.72 so on degrees. That would be the measure of this angle C. So to get the measure of an angle, all you have to do is get two sides, and the angle that they connect will be the angle that's measured. Press the wrong one. deselect. Okay, now the last one is to find the area, and in that case all we have to do is select this side, select this side, and select this side. We've selected all three sides. The area of that triangle is 11. The Fostering Mathematical Thinking in the Middle Grades is a book in the Cascio Fostering series. It contains investigations based on the Common Core Math Standards and focuses on expanding students' understanding of mathematics. The main belief of the author is, if students will truly understand a topic in mathematics, then a teacher will need to explore before explain. Let the students discover what is happening before you build on their education. I hope this has helped you tonight. I gave you quite a few different investigations to use, bringing out the integers, whether it's working with just the integers as the number line, the integers with graphing, the integers with plotting points, but I gave you many different areas to work with. I hope you enjoyed this webinar, and if you have any questions or would like to ask me anything, again, my name is Deb Heckathorn. Here is my email address. It's dheckathorn@msn.com. In the subject area, please put in Integer Webinar so I know that this is not junk mail. I hope you've written that down. I would like you to I'd like to thank you for joining me tonight. I hope you enjoy the rest of your summer, and if you are one of those middle school teachers, again, I have a great respect for the work you do with the middle school students. And thank you very much. Good night.
Thank you, Deb. Thank you, and thank you to those who joined us. And you can certainly contact Deb if you have any questions. You can also contact me as well at naustin@cascio.com. And I just also want to share with you, we have a webinar, I'm sorry, not webinar, an online training available at this website for our Cascio Prism that Deb was using. And if any of you are interested, you can sign up for that and investigate a little further. So thanks again for joining us. Thanks again, Deb, and I hope everyone has a good night.